The next problem is find VO of t using Laplace. Given Vs of t, Vs of equal to, we have 3 U of t minus 3 U of t minus 1, which is equal to 3 dt U of t minus U of t minus 1. Getting the Laplace of this function, so Vs of s equal to 3 over s times 1 minus e to the negative s. So first, let's transform our circuit to the frequency domain. We can simplify the circuit into a single loop. We have Vs, we have Zeq, where Zeq is equal to 2 in parallel with 1 over s, equal to 1 over s plus 0.5. So by VDT, you can solve for VO in terms of Vs. So by VDT for VO is equal to Zeq over Zeq plus s times Vs. We have 1 over s plus 0.5 over 1 over s plus 0.5 plus s times Vs. So simplifying this equation, we have 1 over s squared plus 0.5s plus 1 s. So if our equation for Vs is this one, our VO is equal to, we have 1 over s squared plus 0.5s plus 1 times t over s times the quantity 1 minus e to the negative s. Or we can distribute this factor. We have 3 over s times s squared plus 0.5s plus 1 minus 3e to the negative s over s times s squared plus 0.5 s plus 1. And now we can get the inverse Laplace of VO. So to get the inverse Laplace of VO, we need to use partial fractions. We need to find the equivalent of 1 over s times s squared plus 0.5s plus 1. This is equal to a over s plus bs plus c over s squared plus 0.5s plus 1. Now solving for the values of a, b, and c, 1 equal to a squared plus 0.5 as plus a plus bs squared plus ds. combining like terms, we have a plus b times s squared plus a 0.5a plus c s plus a is equal to 1. So we can generate three equations from this. We can see that our a equal to 1, a plus b is equal to 0, and 0.5a plus c is equal to 0. So using the value of a equal to 1 or b equal to -1, our c is equal to -0.5. So we have 1 over s minus s plus 0.5 over s squared plus 0.5s plus 1. For this term, we can directly get the inverse Laplace. But for this term, we cannot directly get the inverse Laplace the table, so we need to manipulate this term right here. So by looking at the table, we can manipulate this equation so that we can achieve this form and this form. So what we need to do is we need to complete the square of this denominator. So this becomes 1 over s minus s plus 0.5 over, by completing the square, becomes s squared plus 0.5s plus 1 over 16, and we have plus 1 minus 1 over 16. So we added 1 over 16, so we need to subtract also 1 over 16, so to make the equation the same. Now this becomes 1 over s minus s plus 0.5 over, we have s plus 1/4 squared plus 10 over 10. We need to add something here at the top, so we need to add 1/4 minus 1/4. We have 1 over s minus, we have s plus 1/4 plus 0.5 minus 1/4 over s plus 1/4 squared plus 15 over 16. Now we can separate these two terms. We have 1 over s minus, we have s plus 1/4 over s plus 1/4 squared plus 15 over 16, 0.5 minus 1/4, so we have 1/4 over s plus 1/4 squared plus 15 over 16. So looking at this term right here, we know that this is of the same form with this equation, where a is equal to 1/4 and our omega squared is equal to 15 over 16. We need to transform this term into this form. Since our omega squared equal to 15 over 16, our omega is equivalent to square root of 15 over 4. We need to have the denominator as equal to 15 or square root of 15 over 4. So 1 over s minus s plus 1 over 4 over s plus 1 fourth squared plus 15 over 16 plus we have 1 fourth times 15 over 4 s plus 1 fourth squared plus 15 over 16, and we need to multiply this with total of square root of 15 over 4, so we have 4 over square root of 15. So let's say this is our g of s. Now our VO of s is equivalent to p times g of s minus e to the negative s g of s. So getting the inverse Laplace of v of s, I have 3 times 1 minus the inverse Laplace of this term is e to the negative 1 fourth t cosine of square root of 15 over 4 t, and plus 1 over square root of 15 sine of square root of 15 over 4 t u of t, and minus 3 times our Laplace transform is multiplied with e to the negative s, so we have a time shift of 1. So comes 1 minus e to the negative 1 fourth t minus 1 cosine of square root of 15 over 4 and t minus 1 plus 1 over square root of 15 sine e to the sine of square root of 15 over 4 t minus 1. We have u of t minus